Welcome. This video covers writing R functions. We have learned a few different ways that we can sort of try to optimize our R code, or at least improve it. The main way that we can actually improve our code is to learn to write our own functions. If we can learn to write our own functions, we can take little tasks that we do and split them up into their own functions and then just call that function. And that makes our code much more readable. And it's not really that hard to learn how to write your own R functions. What we're going to do is use the syntax that you see here. We're actually going to create a new R object. So this is going to be an R object. And this thing is going to be an R object that is a function, just like the exp function is a function as well. So we're going to create a new R object that is a function, and so we need to use this special way of creating it. So we're going to store in that R object a function that has these inputs, and then we use a curly bracket, and then we put whatever the function should actually do here, and then we can return a value with return if we want. Otherwise, if we don't explicitly specify what should get returned, R will just return the last line of code, whatever the result of that is in the function. So it's not going to be that hard to actually create your own R functions. Let's look at some of the functions that we've already been using and the code that comes from those. And it's actually pretty easy to get a look at most code that underlies these functions. If you just type in a function without the parentheses itself, usually it will show you the code that runs underneath. So for instance, here's the var function without parentheses. It will just print out the code that it runs underneath. And you can see that it's a function with these inputs. Here's a curly bracket, and then this is the code that's actually going to evaluate when you call that function. Call means is another function we've used. And similarly, you can see, oh, here are the different arguments. Anything with an equal sign, these are default arguments, which means that if the user doesn't specify that thing, it's going to default to false. And so oftentimes these functions that people use, they put first a bunch of checks to make sure everything works and everything is of the correct type. So there's usually a bunch of if statements at the top, and then they have the code that actually does the computation of interest. Some functions are a little bit harder to look at, which is annoying. So if I just type in mean, it says this. Well, this is because this is a generic function, so it's hard to get at. But you can look at particular versions or particular flavors of the mean function. So mean.default, if you type that in, this is the default method for calling mean. And so you can then see the code that underlies that one. All right, so we know the syntax for creating our own R function, and we've seen some of the code there. Let's go ahead and try to write our first function. We're going to try to create a standardized function that's going to take in a vector of values. So the input will be a vector of values. And what we're going to do to that vector of values is we're going to subtract off the mean and then divide by the standard deviation. So we're going to standardize that vector. So this is the idea of a z-score, if you've heard of that. So for instance, for the ith element of my vector, I'm going to be subtracting off the mean and dividing by the standard deviation. How do we do that? Let's take our syntax that we had up here and convert it to our function. So we're going to create a new function, and we're going to call that standardize. So this is actually the name of my function. This function is going to take in one argument, so this is my input. I only have one, and there's no default for it. And what am I going to do with that thing? Well, that object that is passed as vector, I'm going to take vector and subtract off the mean of that vector, and then divide by the standard deviation. Remember that R does math element-wise on vectors and matrices. So vector is actually going to have a number of values in it, one-dimensional, and every one of those values will subtract off the mean and divide by the standard deviation. And that is what I'm going to return. So this computation is what is returned. And this thing is going to be a vector. Right? If I take a vector, subtract off the mean, divide by the standard deviation, it's still going to return a vector in that case. So the return function explicitly says return the result of this computation. All right, not too hard. Let's go ahead and create some data and then standardize it. I'm going to run data, or I'm going to create a new object called data using the runif, so random uniform values. I'm going to grab 5 of those. And I'm going to just run standardize on that data object. And so when I look at that, the values have definitely changed. Have they changed to have mean 0 and standard deviation 1, as standardizing them does? Well, we can check that. Look at mean of the result, that's approximately 0, and then standard deviation of the result, it does come out to be 1. So that's great. Our function is doing what we want it to, at least on this case. What else can we do here? How can we make this a little bit more complicated? Well, we can make centering optional and make scaling optional. To do that, we can just add 2 more inputs that the user can give us. So they can give us a center argument and a scale argument. And the way that this is set up, this should be a true or a false value for both of these. And so in the documentation, you would want to specify exactly what the argument should be. And when you look at the help for any R function, you do see that kind of thing. They have the values down below and what each one of them should correspond to. But if these things are trues or falses, I can just run an if statement on them. So if center is true, then I'm going to take my vector and I'm going to subtract off the mean. If scale is true, I'm going to take my vector and divide it by the standard deviation. And then I'm going to return my vector. If center were false, I'm going to skip the evaluation of this. If scale were true, I would still divide here. So it would be a scaled vector that I'm returning, but not a centered one. And so we can run that here. I'm going to go ahead and standardize it using center true, scale true. So this is exactly what I had before. Here I'm going to do it with center equal false, but scale equal true. So they are no longer centered, but they are scaled appropriately. Now, of course, you don't necessarily want to make the user give all of the arguments if most of the time they're going to center and scale, for instance. So we can go ahead and give default arguments. So these are now the default values for center and scale. Unless the user specifies that they should be something else, those are the values that they're going to take on. And so now I can call either this line or this line, and it does the exact same thing because center by default is true and scale by default is true. Okay, we can also return more than one thing. So generally speaking, R functions just return one object. However, we know about lists, right? And lists are one object, but it's a very flexible object. In fact, it's one-dimensional, and in each element, I can store whatever I want. And so maybe I want to return that vector of possibly standardized values along with the original mean and original standard deviation of the data. Well, all I need to do is, in this case, I need to make sure I save the mean and standard deviation up here so that I have them to return. And then I can take my vector, and if they choose to center it, center it. If they choose to scale it, scale it. And then I'm going to return not just the vector, but I'm going to return the vector, the mean, and the standard deviation as a list. So again, I'm still returning one object. It's just that this object now has 3 elements to it. And so if I run this function now, and I look at the result, I get my standardized vector. I get my mean. And I get my standard deviation. However, this isn't ideal, right? I don't have names here, and this is hard to understand what gets sent back to me. And in fact, if I wanted to grab one of those pieces, I have to use some of that old-timey base R double square bracket business. Not great. And so, of course, we know how to do a named list, so let's just name those list elements. If I just name the first one result, name the second one mean, and the third one standard deviation, or SD, whenever I call this function, I now get returned that list that has names associated with it. And this makes it much easier to then grab a particular element of that list. Not only that, but it's more descriptive as well. And then lastly, let's just talk about the idea of anonymous functions. Anonymous functions are sort of just functions that you write inline. So ones that you're not going to save for later use, but you just need to use during this one particular function call. These come up a lot whenever you're using functions from the apply family. As an example, let's go ahead and just make a Tibble version of iris. So this iris dataset has information on flowers. We've looked at once or twice. And so we're just going to make a Tibble version of that. And let's suppose that what I want to do is summarize the numeric columns of that. And the summaries that I want to find are the mean, the median, and the IQR. Well, I can use the apply function to write an anonymous function that will do that for me to each numeric column. So I'm going to do apply, and I'm going to give it the first argument, which is the numeric version, the numeric parts of that Tibble above. So it's just going to look at these 4 columns. And then I'm going to say to the margin 2, remember that margin 1 is rows, margin 2 is columns. So to each column of this matrix or data frame, I want to apply this function. I'm going to write an anonymous function here. So this is an anonymous function So I'm just writing it in line. I'm saying a function of x. So x is the object that it's going to take in. And what is it going to do? It's just going to find the mean of x, the median of x, and the IQR of x. And this is the only line of code, so that is what's going to be returned by that function. Not only that, but I'm naming these arguments as well. So this is an anonymous function. You're not going to have this function for use later, but it's being used within this apply function. And the way to think about this is, again, what we're doing is we're applying this function to each column of our data frame. And so the first time that you're thinking about this is it's grabbing this as the x. So this is my x the first time this thing evaluates. Again, it's really looping underneath. And so that's the x that's going to be put in here. So whenever you think about how to use this within your function call, consider it to be this column of the data. So I have a column of data. Well, okay, I can just find the mean of that column. I can find the median of that column. I can find the IQR of that column, because that's the type of argument that each one of those functions takes in. The next time that this thing evaluates, this will be the x. And so that's the way to think about writing these inline functions. If you're going to do margin equal to with apply, it's going to be pulling in each column that you do. So that's the thing, that's the x that you're going to be playing around with and working with. If you did rows, it's going to be pulling a row each time, and that's the x that you're going to be playing with. Let's go into R and create a custom function that we can use. All right, here we are back in R. We're going to again stick with that same tasks we were doing before, where we were trying to fit different simple linear regression models for this quality variable. And so we were trying to automate this process and make it a little bit easier to do. Well, we're going to stick with using this myFormulae object because we kind of need those formulas no matter what. But how can I simplify the rest of this using a custom function? So let's go on down here. We're going to write a function to fit the LM, the linear model, and pull out the coefficients. So let's just assume that that's the only thing that we want right now. So I'm going to create a new R code chunk down here. Let's go ahead and call this object getCoef. And we're going to save in this getCoef R object a function. This function is going to need to take in a few things to do the linear model fit and return the coefficients. So to do the linear model fit the way that we have it above, we're going to need to take in a formula. So formula will be the first argument. And then we need the data for the linear model as well. So we're going to go ahead and take in a data argument too. And then we'll put curly brackets, and then here's the body of the function, the actual code that's going to evaluate. So I'm going to create an object in here called that's a linear model fit that uses the formula passed and then uses the data passed as well. With that, I then want to grab the coefficients. And this is what will be returned if I made this my function, because that's the last line of code. But to be explicit about it, I could just put return here. Make sure that we know that that is what's going to be returned, is the coefficients of that fit. Let's just try our function out real quick and make sure that it works. So we'll say getCoef, the formula that we want to pass. Well, we have a whole vector of formulas, if you remember, up here in an object called myFormulae. So I'll say myFormulae, and we'll just grab the first one. And the data we're going to pass is my wine data. If we run that, it just returns the coefficients from that linear model fit. Great, so really what I now want to do is just apply this same getCoef function to every element of my formula. So now I'm going to say use lapply. We'll go ahead and say lapply. The x that I want to apply it to is the myFormulae object. And then the function I want to apply to it is the one I just created myself called getCoef. getCoef does have another argument though, data, so I need to make sure I pass data as well. Let's run that. Oh, sorry, I didn't specify what the data was. Losing my mind. We need to put my wine data here as the argument for data. So we'll run that, and now we get spit back out all the different coefficients for those linear model fits. Again, if we want to make that a little bit easier to look at, let's use sapply instead, which will simplify the result. And there we go. We got the same issue with the row names, but that can be handled on the back end. So very easy to write our own functions to use throughout R. All right, hopefully doing all of this function stuff has excited you. As you learn to write your own functions in R, that's really when you become a really good R programmer, because you'll start to read other people's functions and you'll start to really understand how R is working whenever you call functions and do your analyses and things. There's a lot more to know about functions that we didn't cover here. So there's a few terms down there that you might want to familiarize yourself with if you're going to go a little bit further with writing your own functions. But this wraps up this small section on improving your R programs.